Okay. Afternoon, ladies and gentlemen. It's Mr. K here speaking. I hope everybody's doing okay. All right. I won't waste any of your guys' time here. Let's get started right on number 11. All right. This is the rest of week 2. Okay. So the question's asking which pair of equations would have negative 1/2 comma 2 as a solution. All right. So what it's asking here, okay, is which one of these pairs of equations, okay, does this point fit in for both of them? Okay, so which equation is this point true for both? Okay, so what I mean by that is this. So if you take a look at number 1, all right, what I'm going to do is this is our x value, these are our y values, right? Right? When we're talking about a pair of, or a coordinate pair. Okay, so what you're going to do is you're just going to take this x and y value and plug them in for x and y in each one of these equations. Okay, now essentially you could plug all these into your calculator. Okay, those are both the correct methods. Okay, so you could either take these and plug them into your y equals, or you could just take this point and plug them in for your y and x value, which runs the risk of maybe making a mistake. Okay, so what I want to do here is I just want to show you what I mean by at least plugging them in. Okay, so if you want to do it algebraically, that doesn't tell us to do it algebraically, but if it did, all right, so what you do is you take this y value. Okay, we're looking at this point right here, remember, okay? So I'm take my y value, which is a 2, plug it in for y, whoops, is equal to negative 1 plus 3, whoops. Okay, so what I did was I substituted my x value in for anywhere I saw an x, and my y value anywhere I saw a y. Okay, so in this case, what's negative 1 plus 3? It's 2. So we get 2 is equal to 2, which checks out. Okay, now, if you were to plug x and y values in for this, okay, what you would get is you would get 2 is equal to 2 raised to the negative 1. Okay, now we haven't really talked about these types of powers right here yet. All right, anything raised to the negative power, but we could still plug that into our calculator, right? So you could go 2 caret button raised to the negative 1. When you plug that into your calculator, you should get 0.5. Okay, so this is not equal to that. So we would cross out that point. But anyway, what I would suggest doing is, because all of these are set equal to y except for this one here, okay, I would just plug these into your y equals. All right, so let's take a look at this one right here, number 2. So everybody just goes to their y equals, and you're going to type in y equals. For your first equation, it's going to be x minus 1. For your second equation, it's going to be y equals 2 caret button raised, or I'm sorry, not caret button, I'm sorry, it's just 2x. My bad, wrong problem, right? So it's just going to be y equals x minus 1, y equals 2x. You go to your second table. Okay, so when you hit second table, you go to the point negative 1 comma 2. I'm sorry, you go to when x equals negative 1, and you can see x is actually equal to negative 2 for both of these cases, all right? So this point fits for both of these, right? But we're actually looking for a positive 2, not negative 2. So that one's out, okay? Let's try this one right here. All right, let's plug that into our y equals. So go y equals, you're going to go x squared minus 3x minus 2. And then you go to the second y equals, and you just type in 4x plus 6. Okay, so in your y equals button, you should have this equation right here, and this equation right here. Okay? And then you go to your second table. Now we should already be at negative 1 when x equals negative 1. As you can see in both problems, when x is equal to negative 1, y is equal to 2. Okay, so because we know that one's in, we can cross all these other ones out. And so our answer is number 3. Okay, so you just put down here at the bottom, use your y equals button. Okay? All right, so use your y equals button, plug in both of those equations, all right, and see which one of these pairs of equations has this point for both of them, okay? So actually this is also what you want to call a system of equations, right? So what we just did is we found that the solution, okay, when we graph both of these lines, okay, when they intersect at -1, 2, okay? So that's what kind of problem we just solved there. Okay, so that was a system of equations problem. All right, let's take a look at number 12. Okay, so number 12 is a bit tricky. All right, so let's read the problem here. A parking garage charges a base rate of $3.50 for up to 2 hours and an hourly rate for each additional hour. The sign below gives the prices for up to 5 hours of parking. Okay, so the question's asking, all right, which linear equation can be used to find x, the additional hourly parking rate? Okay, so x in this case, all right, isn't technically our output, right? It's our additional hourly parking rate. Now, when we're talking about rate, okay, if you remember in the beginning, or if you've looked at the title of this week, all right, we're talking about linear equations, right? So when we're talking about rate in linear equations has a special name for rate, okay? When we're talking about rate in linear equations, we're actually talking about the slope, right? Because when we're talking about linear equations, we're talking about lines, right? And lines have a constant rate of change. Okay, so when we're talking about rate here, we're talking about the slope. All right, we want to know how much it's increasing by each time. All right, so let's make sure that it is linear. Okay, so after 2 hours, whoops, let me do that. Okay, so after 2 hours, it looks like it increased by $5.50. And if you look at all the cases, okay, between each one of these data points, it's going up by $5.50. Okay, so that is our hourly rate for each additional hour. All right? It is going up, its slope, or its rate, all right, it's $5.50. For each additional hour, it's $5.50. Okay. Now, we're going to have to look at each one of these linear equations and find which one of these has the correct additional hourly rate. All right, and there's a couple ways you could solve this. Okay, we could either solve for x, right, which would be kind of lengthy, or since we know the slope, okay, let's just find out which one of these has the correct rate here. Okay, so if you take a look at this first one here, all right, if we plug in $5.50, okay, so we would go 9 plus 3 times $5.50 equals 20. So let's see if that works out. 9 plus 3 times 5.5, and you get 25.5 is equal to 20, okay, which is not a true statement. So this guy's out. Right? Let's try it for this one right here. So you go 9 plus 350 times 550. What do we get here? Well, we know this one's going to be wrong anyway, because if with 3, we went above 20. 350 is certainly going to put us above 20. So I'm not even going to waste my time doing that one. So that one's out. All right, let's take a look at number 4. So 2 times 550 plus 9. What does that equal? You get 20. It's 20 equal $14.50? Absolutely not. So that one's out. So it has to be number 3. But let's just verify here. All right, so when we go 2 times $5.50 plus $3.50, so 2 times $5.50 plus $3.50, you get $14.50 is equal to $14.50, which checks out. So number 12, the correct answer is number 3. Okay? All right. Let's take a look at number 13. Which situation can be modeled by a linear function? Okay? So we're talking about linear functions again. All right, they have a special name for that rate. They call it the slope. Okay? And we got to remember when in a linear equation, your slope is always constant. It's that constant rate of change. Okay? So, let's take a look at which one of these problems has a constant rate of change. Okay, so take a look at number 1. The population of bacteria triples every week, which means it's being multiplied by 3 each time, right? You're starting, let's say your population of bacteria starts at 1, the following it's 3, okay, the following week after that it's 9, so you're kind of goes back to that system of, or your sequence unit there, right? So you start with 1 bacteria, it triples, now you're at 3, all right? Now that triples, so now you're at 9. And then that triples, now you're at 27, okay? So that one's out. This is an example of an exponential function, okay? How about this one? Number 2, the value of a cell phone depreciates at a rate of 3.5% each year, okay? So what's happening here is anytime you see a percentage, okay, what that means is it's multiplication, all right? When we're talking about when a rate is some sort of percentage, all right, what's happening is your phone is depreciating by 3.5% each year. So let's say, for example, your phone was worth $100, okay? So the following year, right, it depreciates by 3.5%, which means your phone is now worth $96.50, okay? So then you take that number, and now that number gets multiplied by 3.5. So you go 96 times, I'm not sorry, 3.5. You gotta remember this is, when you multiply, okay, when you're multiplying percentages, this is actually your percentage you're multiplying. That's your rate, okay? You gotta move the decimal place over twice. All right, so you take 96.5, you multiply it by 3.5%. And now your phone is worth 93.1225, okay? So as you can see, we're not going down by the same rate, okay? This one here, we're going down by 3.5, okay? 96.5 minus 93.1225. All right, now we went down 3.375, all right, and so on and so forth. So anyway, 2 is out. Okay, so let's take a look at number 4. All right, a baseball tournament eliminates half of the teams each round. Okay, so let's say we started out with 20 teams. All right, so now that's round number 1. All right, think back to your sequences. So round number 2, how many teams are left? 10. All right, after the 3rd round, how many teams are left? 5. Okay, and so on and so forth. All right. Now, so because we're eliminating half of the team each round, right, as you can see, first round we went down 10, second round we went down 5, the 3rd round, I mean, it's not even numbers, so I don't know how that would exactly work, but anyway, this one is out, okay? Let's take a look at number 3. Amusement park allows 50 people to enter every 30 minutes, okay? So let's take a look at the first 30 minutes, okay? First 30 minutes pass, they let 50 people in. Second 30 minutes pass, all right? They let another 50 people in. So how many people are in there? 100. Another half hour passes. Now we're up to 150. Okay? So what's happening is it's increasing by the same amount each time. And when we're talking about linear functions, we're talking about a constant rate of change. So number 13 is number 3. Okay, number 14. Last weekend, Emma sold lemonade at a yard sale. The function P of C is equal to 50 cents times C minus 9.96, represented. Jeez, that's a mouthful. Okay, the function here represented by the profit, P of C. Okay, so P of C, or our output, is how much money we make. Okay, Emma earned selling C cups of the lemonade. All right, so here's our function. Our output is the profit, and C is the amount of cups of lemonade she sells. Okay, so sales were so strong, she raised the price for this weekend by 25 cents per cup. Which function represents her profit for this weekend? All right, so let's think about this. So P of C is our Y values, right, or our output. Okay, in this case, it's our profit. And C is your X values, your input, whoop, and in this case, it's the cups of lemonade. All right? And so let's take a look at our function here. So this function is P, C. Now, let's think about this. Okay? So, when C is equal to 0, that means we are at our function, P of 0, is equal to negative 9.96. Okay? So that, right here, ladies and gentlemen, is actually what we like to call our y-intercept. Okay? So when we've sold 0 cups, we're actually at negative 0.96. Okay? So this is our y-intercept, right? Okay, that's what this number at the end represents. Put that in a different color. Okay? And so that means this right here is our slope. Okay? And so let's think about what's being multiplied by our slope. Well, it's the amount of cups she sells. Cups of lemonade. Which means this number right here represents how much she's making per cup. So it looks like the price of a cup of lemonade is 50 cents. So price per cup, or our slope, okay, is 50 cents. And now she raised the price for this weekend by 25 cents. So our new price is no longer 50 cents. It's 75 cents. So our slope is no longer 50. It's 75. So which one of these is our equation over to the left? Option number 4. Okay, so that's number 14. Number 15. All right, so it says one characteristic of all linear functions is that they change by. All right, so this is a multiple choice, and it looks like we're just trying to think about which one of these answers down here is the correct one. Okay, so one characteristic of all linear functions is that they change by, okay, equal factors over equal intervals, unequal factors over equal intervals, equal differences over equal intervals, or unequal differences over equal intervals. Okay, so that's quite the mouthful there. All right. So let's take a look at which one of these makes the most sense. let's see, I'll put number 3 here. Okay, so here's what a linear equation looks like. Y equals mx plus b, right? And so a lot of times what happens here, okay, so let's just pick a function. Let's go y equals 2x plus 1, okay, something simple, right? So our y-intercept is 1, right? When you plug in a 0 for x, you get 1. When x is equal to 1, you get 3. When x is equal to 2, you get 5. X is equal to 3. 7 is equal to 4. You get 9, and so on and so forth. Okay? So what's happening here is we're increasing by 2. All right, so let's talk about options number 1 and number 2. Right? When we're talking about factors, okay, we're talking about multiplication. All right, so are we multiplying each time here? No. Okay, we're adding each time. So 1 and 2 are definitely out. Okay, because we're not talking about factors. Right? We're not multiplying here. So it has to be 3 or 4. Now, equal differences over equal intervals or unequal differences over equal intervals. Okay, so what that's saying by this part right here, all of these, if you notice, it's all the same in each. So what it means is our intervals, it's like our x values, right? Which is increasing by 1. All right, so for each value, all right, because we typically use integers, right? You know, when we're plugging in values for x, okay? So as we increase by 1 each time, okay, we're looking for equal differences. Okay, so as you can see, our difference between 1 and 3 is 2, 3 and 5 is 2, 5 and 7 is 2. All right, we're increasing by the same amount. So we don't want unequal differences. Okay, so our answer is number 3. Okay, we were talking about equal differences over equal intervals. Okay, so that is number 15. All right, we're going to take a break here. Actually, should we just keep going? Might as well keep going here. All right, let's just finish out the rest of this unit. Okay, so that's number 15. Number 16. Okay, it says, during physical education class, Andrew recorded the exercise times in minutes and heart rates in beats per minute, BPM, of 4 of his classmates. Which table represents a linear model of exercise time and heart rate? Okay, so we're looking for a linear model. So when we're talking about linear model, we're looking for that constant rate of change, right? In this case, our slope. Yes. Okay, so in all of these cases, if you look, they're all increasing by 1. Our x values are all increasing by 1. So the left side is good. All right, and for all of these, all 4 problems, we just have to look at the right side and see which one of these is increasing by the same amount each time. So this one increases by 3, 1, 7. Okay, so that one's out. All right, how about this one? This one increased by 7, 5, 5, 4. Okay, that one's out. 8. 13, 5, okay, that one's out. And so if you look at this one, increases by 5 each time. So number 1 is the correct answer for 16. Okay. Number 17. All right, it says the solution to this problem is. All right, now you got a couple options here. All right, so here's our problem, and one of these values is true for this equation. All right, so in order to find that, there's a couple of options we could do. We could take this value and plug it in for all of our x values. All right? Or we could solve for it algebraically. Okay, so one of your options is just take that value, plug it in for x, see what happens. But if it does say to solve this algebraically, okay, you might want to make sure you know how to do this as well. Okay, so this is a multi-step problem. All right, so in order to solve it, we need to distribute that 2. So we get negative 2 plus 8x is equal to 3x plus 8. Subtract 3x. Get negative 2. Oops. Plus 5x is equal to 8. Add 2 to both sides. You get 5x is equal to 10. Divide by 5. X is equal to 2. And do we see that over there? We sure do. Okay? And I guarantee if you were to take this value, plug it in for both those values of x, you get the same thing on both sides. So that's how you can check. All right. Number 18. Okay? Each day a local dog shelter spends an average of $2.40 on food per dog. It's expensive. Shelters aren't cheap, let me tell you what. Support your local shelters. Anyway, the manager estimates the shelter's daily expenses, assuming that there's at least one dog in the shelter, using the function e of x is equal to 30 plus 2.4 times x, right? Which statement regarding the function e of x is correct? All right, so let's take a look at what this function actually means before we start breaking down what this is here, okay? Now, typically when we write functions, we have it what? Y equals mx plus b, right? So as far as the left side goes, I mean, that's still just our output, all right? But if you notice on the right, we don't quite have it in that slope-intercept form. So let's change that. Now it looks a little more familiar than what we have, or than what we got above there, okay? So let me start labeling some stuff here. So this right here, this is our output, right? Our y values. Okay. Right here is our y-intercept. Write that in a different color. For those of you that are colorblind. Y-intercept, which means this little piece in the middle here is our slope. Okay? So, in this case, this function, okay, the manager estimates the shelter's daily expenses using this function. So this function gives us our daily expenses. All right. Assuming that there's at least one dog in the shelter using this function. So the x then, all right, let's read up here. The average is $2.40 on food per dog. Okay, see this per here, right? This is our slope. So per dog. So what that means is $2.40 per dog. So our x values are our input. Is just the number of dogs in the shelter. Okay? Just the number of dogs in the shelter. All right. So, we've just kind of just dissected what this function really means. All right? So, let's read down through our choices here and see which one of these doesn't make sense, or maybe they all make sense. We don't know. Okay, so X represents the number of dogs at the shelter per day. Okay, this one's correct. X represents the number of volunteers at the shelters per day. That one is wrong. 30 represents the shelter's total expenses per day. or I'm sorry, 30 represents the shelter's total expenses per day. And then also says 30 represents the shelter's non-food expenses per day. So let's take a look at what this third one means. It says 30 represents the shelter's total expenses. Well, that one's wrong because the function actually gives us the shelter's total expenses, all right, per day. Okay, so 30 actually represents the shelter's non-food expenses because let's face it, okay, you need more than just food. You got to pay for shelter and rent, heating, and tools, all sorts of stuff. So the 30 represents the amount that's extra per day. Okay. So as you can see, as the week progresses, it gets expensive depending on how many animals you have in there. So anyway, number 2 is the answer to number 18. All right, number 19. At the table below shows the values of 4 different functions for given values of x. Which table represents a linear function? So again, we're just looking for that constant rate of change. Okay, and the only one that has that here is the first one. It's going up by 7, 7, 7. Okay, if you look at this one here, it goes up by 3, or I'm sorry, 2. Yep. Then it goes up by 4, and it goes up by 8. Okay, so that one's out. This one increased by 3, 4. I'm sorry, geez, I can't add. 3, and then 5, and then 7. So that one's out. 6, and it went up by 10. Then it went up by 14. Okay, so that one's out. So our linear function is f of x, right? We're looking for that constant change in the y values. Okay, that's number 19. Number 20. The line represented by the equation 4y plus 2x is equal to 33.6 shares a solution point, and the line represented by the table below. So a solution for this system is, all right, so what we're looking for here, all right, is we're looking for this point, okay, to be a solution to both of these functions here. All right, so this is kind of like a system of equations problem. Okay, and so what we're looking for is a solution point, okay, or a point where these two lines intersect. All right, now what you want to do, and your easiest method, is to take these points, okay, and plug them into that equation right there. All right, and so if it doesn't match up, then we know that that point is out because it has to be a solution for both. All right, so if you do this for this first one, okay, so let me just set you up here. So it'd be 4 times negative 1.4, all right, plus 2 times negative 14. And does that equal 33.6? Well, it does. Huh. Strange. Thought when we worked on this problem the other day, it didn't match up here. Huh. Interesting. Okay. Well, weird. When we were doing this problem the other day, Shelly said this didn't work out for all the other ones. Or she just plugged all these in. And it didn't come out here, right? 4 times negative 1.4 plus 2 times negative 14 came to, oh, negative 33.6. Okay. Yeah, so that's out. All right, so that point doesn't work. Sorry, I got nervous there. I was like, man, it's like it shouldn't work out. Thought it didn't. Okay. So this is actually equal to negative 33.6, okay? Which is not true. So this point doesn't work, and then if you take this point and plug it in for x and y, this one wouldn't work, and this one won't work as well. Okay, your correct answer for number 20 is 4. All right, so if you take this value, plug it in for this one, all right, you would see that you would get 33.6, which is equal to 33.6, and this is the only point that will work for this equation up here. Okay, so number 4 is the answer to number 21. Okay. So it says, Sue and Kathy were doing their algebra homework. They were asked to write the equation of a line that passes through the points -3, 4, and 6, 1. Sue wrote this, and Kathy wrote that. Justify why both why both students are correct. Okay. So, in order to solve this problem, we first want to make sure, okay, that they have the right slope. Because it looks like they have the same slope in each case. Okay, so let's make sure they got the same slope. So in order to find the slope, okay, we got to use this equation right here. All right, this is the point slope, whoops, write it like that, point slope formula. Okay, so when you use the point slope formula, all right, you're going to go y2, which is 1, minus y1, which is 4, for x2, which is 6, minus x1, which is -3. So you get 1 minus 4, which is -3, over 6 plus 3, which is 9. So you get -3 over 9, which is just a -1/3. Okay, so they do have the correct slope, so which is good. Now, let's take a look at what they have written down in here. Okay, both of these girls are correct. Right, Sue and Kathy are correct, and I'm going to show you why. All right, so if you take a look at what Sue wrote. Okay, if we wanted to simplify this problem, right, we would distribute. We have y minus 4 is equal to -1/3 x minus 1. And then you add 4 to both sides. And voila. So Sue and Kathy actually have the same equation. Okay, so justify why both students are correct. Okay. We would say because Sue and Kathy have the same equation. Okay, one is in the point slope formula and the other is in the slope intercept form. Okay, all right, and we just shown that Sue and Kathy have the same equation. Okay, and they got the correct slope. All right, so we're good to go there. So because Sue and Kathy have the same equation, one is in point slope and the other is in slope intercept. Okay, so Sandy programmed a website's checkout process when the equation Blah. So Sandy programmed a website's checkout process with an equation to calculate the amount of customers will be charged when they download songs. All right, the website offers a discount if one song is bought at the full price of $1.29, then each additional song is 99 cents. State an equation that represents the cost C when songs S State an equation that represents the cost C when S songs are downloaded. So Sandy figured she would be charged $52.77 for 52 songs. Is this the correct amount? Justify your answer. Okay. So, in order to find our equation, okay, we need to first figure out what that equation is. So in order to do so, okay, let's take a look at what we have first. If one song is bought, we have the full price of $1.29. Okay, so when one song is bought, our output, okay, is $1.29, right? Because that's what this function does. Okay, this function is used to find the cost. So our cost for one song is $1.29. So this is kind of like our first point, x1, y1, right? And so then each additional song is 99 cents. Okay, so if I downloaded 2 songs, okay, so the first one was $1.29, then my second song would cost 99 cents. So I'd take $1.29 plus 99 cents equals $2.28. Okay? And so now we have 2 points. So in order to find out in order to find our equation, we need to find our slope. Okay, so in order to find the slope, we got to go y2 minus y1 over x2 minus x1. And so we get 228 minus $1.29 over 2 minus 1. And what do you think we should get here? How much is it increasing each time? How much did it just go up? Should be 99 cents. So here is our slope, right? For each additional song, it's 99 cents. Okay? And so now we have our slope. We just need to plug it into this equation right here, which again is the point slope formula, except all we need is one set of points. So in this case, I'm going to choose this one. So I'm going to go y minus $1.29 is equal to 0.99 times x minus 1. Okay, when you distribute that in there, you get y minus is equal to 0.99 x minus 0.99. And all said and done, I'm running out of room here. Okay, your function should look like this. Y is equal to 0.99x, okay, plus, and we're going to go negative 0.99 plus $1.29, 30 cents. So there is your equation. State an equation that represents the cost C when songs are downloaded. Okay, so we're not quite there yet. All right, so here's an equation. Right, we need to write it in terms of C and S. So in this case, our output, all right, goes in for our Y, and anywhere you see an X, you trade it for an S. All right, so state an equation. And now Sandy figured out she would be charged $52.77 for 52 songs. Is this correct? We take this equation and we just plug in this point right here. So at 52 songs, what do we get? Right, so when you plug in a 52 in for S, so you go 52 times 0.99 plus 30 cents, and you get $51.78. Okay, so is this the correct amount? We would say no, okay, because $52, she gets $51.78. $51.78 does not equal $52.77. Okay, so is this the correct answer? No, and we justified our answer through our algebra. Okay, so that's number 22. Number 23. Right, Tanya is making homemade greeting cards. The data table below represents the amount she spends in dollars, f of x, in terms of numbers of cards she makes, x. Right? So, the amount she spends in dollars is your f of x. And don't forget, f of x is just a fancy way of saying, excuse me, y. Got the hiccups. All right, so the data below represents the amount she spends in dollars in terms of the cards she makes. So x, right, is the number of cards she makes. Okay? So, write a linear function, f of x, that represents the data. Explain what the slope and y-intercept of f of x mean in the given context. Okay? So, we're going to have to come up with an equation here again. Right? So, I see a couple points here. All right, so I'm going to go 4 comma 750 and 10 comma 12. All right, so this will be my x1, y1, x2, y2. So I'm going to go 12 minus 750, 10 minus 4. .5 minus 6, and you get a slope of 0.75. All right, so here's our slope. Now to come up with the rest of our equation, we just got to steal one of these points. So I'm going to steal this one right here. So this will be our x1, y1, right? So we're going to go y minus 750 is equal to 0.75 x minus 4. We distribute, so y minus 750 is equal to 0.75 x minus, and that should be 3. 4 times. Yep. And then plus 750. Whoops. All right, let me put that extra 0 in there because that means that rates a little more into our problem here. Okay. Now, I'm not quite done yet because I need to write a linear function here. So I just wrote an equation. I need to write this function in terms of f of x. So anywhere I see a y, that f of x there. And there's our equation. Okay? So, let's think about what this means in terms of our problem here. All right? So forget our f of x is our y or our output. I'm sorry. Okay? So we're talking about we need to talk about the slope and the y-intercept. Okay? So our slope here, all right, represents the amount it's our problem's increasing by each time, right? So what's getting multiplied by our slope? It's the number of cards she makes. So that means the number of cards she makes, or I'm sorry, the price of each card that she makes. All right, so the slope is 0.75, and that is your price per card, right? every card she makes, because that's our x value, all right, our x gets multiplied 0.75, which represents the amount she makes, which means that $4.50 represents our initial cost, okay, which is $4.50. Okay? So, those are our answers to, and I think we answered everything, right? Explain what the slope and y-intercept of f of x mean. Right? The slope is price per card, the y-intercept is initial cost, and here is our equation. So we're good. Answered everything there. And number 24. Right, the graph below was created by an employee at a gas station. Which statement can be justified by using the graph? Okay. Well, let's take a look at some of what these things say here, I guess. That might be the easiest one. So it says if 10 gallons of gas was purchased, $35 was paid. Okay. So let's see. At 10 gallons of gas, well, it looks like we're above $35, right? So that means this one is false, okay? For every gallon of gas purchased, $3.75 was paid. Well, let's think about this. At 2 gallons of gas, can't really tell where we're at. Okay, but at 4 gallons of gas, we're at 15. All right, and then at 8 gallons of gas, we're at 30. Okay, the reason why I chose those 2 points is because they fall right on those nice crosshairs, right? Those grid lines there. Okay, so what I'm going to do is I'm going to use this to find the slope, okay? Because that's what this is talking about. For every gallon of gas purchased, $3.75 was paid, okay? So in order to find what our slope is, all right, because this could be the correct slope, we don't know. So we're just going to plug it into this equation right here. All right, so it's going to be 30 minus 15 over 8 minus 4. Let's get 15 divided by 4, which I believe is 3.75. All right, so that is our rate. So our slope is 3.75. And what's happening here is that means for every gallon of gas, we're paying $3.75. And so this one has to be the correct answer. Well, let's make sure the other 2 are wrong. Okay, so for every 2 gallons of gas purchased, $5 was paid. Okay, wrong. Okay, that's at 2 gallons of gas were about 7 or 8. And if 0 gallons of gas was purchased, 0 miles were driven. That doesn't make any sense. Okay, maybe you already filled up on gas. All right, so that one's out. So, number 25, okay? The cost of belonging to a gym can be modeled by this function right here, where CMM is the total cost of M membership or M months of membership. So state the meaning of the slope and y-intercept of this function with respect to the cost associated with the gym membership. Okay, so here's our function. So they just want us to talk about what our slope and what our intercept mean here in terms of our problem. Okay? So this right here is our total cost. Okay, that is our output. Okay? So our input here, right, is the months person's had the membership. Okay? So, which means, okay, that the 50 is our slope, and our slope is the cost, cost per month, right? Right, so each month you have this membership, you have to pay $50. Right, so it's $50 plus, okay, this is like your initial amount, right? Our y-intercept is our initial amount. Whoops. Okay, which is our initial amount, which means All right. It costs $79.50 to join the gym. Okay, so it costs you $79.50 to join the gym, and then for each additional month, you have to pay an extra $50. Okay, so that is what all that stuff means there. Okay, so let me write this over to the side here as far as slope. Cost of membership per month. Okay, and our y-intercept is the cost to join the gym. All right, the initial amount. So we'll just say starting cost to join the gym, right? The initial amount. Okay. And that's all she wrote, ladies and gentlemen. So that is the rest of week 1. Okay, stay tuned for more news and updates about, grades and types of work, and there's going to be quite some changes coming up here. So make sure you guys are